All right, linear equations. So in this and the next couple of videos, I'm going to be talking about linear equations. Maybe a logical place to start is just learning what is a linear equation. If this were a textbook, I might say a linear equation is an equation that can be written in the form ax plus by plus c equals 0. And if I wanted to be really precise and I was talking about a linear equation in two variables, which is what we're going to be doing here, I might specify that a and b can't both be equal to 0 or make some little restrictions like that. But maybe for our purposes, where I'm not worrying about being quite as precise, it might be easier to talk about linear equations or just equations that kind of sort of look like this. Note that here I have three terms. The terms are the things that are separated by plus and minus signs. So this 2x is a term, this 3y is a term, and this 12 is a term. And each of those terms are either constants, meaning just numbers like the number 12, or what are called linear terms, which are just a number times one of our two variables, an x or a y. Note that you don't see any of our variables squared or cubed or underneath the square root sign. Linear equations are kind of the most basic type of equations that we're going to run into. I'm not super worried about any of this vocabulary, although I think it will help the algebra later on in this class to be able to see the different terms in an equation. So if you can see that we have three different terms here, that's really useful. But really what I'm most concerned with this equation, and really all equations in this class, are its solutions. And since we have two variables, the letter x and the letter y, solutions won't be single numbers, but rather pairs of numbers. A value that the x's can take on and another value that the y's can take on, so that the left side of the equation is the same as the right side of the equation. So for example, if x is equal to 9, then I would have 2 times 9 or 18 here. And if y happened to be equal to 2, then I would have 3 times 2 or 6 here. And because 18 minus 6 is equal to 12, x equals 9 and y equals 2 is a solution pair to this linear equation. If you really wanted to check your answer, you could take that 9 and 2 and plug them back into this equation and show that the left side of the equation is in fact the same as the right side of the equation. It's worth pointing out that there's a shorthand way of writing solution pairs like this. Instead of writing x equals 9 and y equals 2, we can just write 9 comma 2 inside parentheses, and implied is that the first number is the x coordinate and the second is the y coordinate. And as you may suspect, 9 and 2 is not the only solution pair to this equation. In fact, there's infinitely many solution pairs. If you felt like it, you could try to come up with a few more on your own. Let's see, I think 6 comma 0 would be a solution pair. Why? Because if x is 6, I get 2 times 6 or 12 over here. And if y is 0, I'm subtracting 0, so 12 equals 12. How about a few more? If x is equal to 0, I guess y would have to be equal to negative 4 in order to make the left side of the equation the same as the right side of the equation. If x is, I don't know, negative 3 maybe, then we have negative 6 over here on the left side of the equation. So I need to add 18 more to make this equal to 12. So to add 18, I'll subtract negative 18. So I'll need y to be equal to negative 6. And while I've only focused on whole numbers so far, it's worth pointing out that there could be lots of fractional solution pairs. If x equals 10, then I have 20 over here. I need to get rid of 8 in order to make the left side the same as the right side. So I need 3y to be equal to 8. So I guess I need y to be equal to 8 thirds. Because 3 times 8 thirds is 8, and 20 minus 8 equals 12. You could play this game for as long as you want, coming up with a whole bunch of different solution pairs for this equation. But really, that might be kind of a waste of your time because, as I already alluded to, there's infinitely many solution pairs, so you're never going to find all of them. But we're interested in all of them. So how can I represent the infinitely many solution pairs that satisfy this linear equation if my goal isn't just to list them all? Well, what you'll see in our class is we typically take 2 points of view to any given topic. We look at things algebraically, like we've done so far, and then we look at things geometrically by considering the graph. Look what happens if I plot each of these points on our coordinate planes. Hopefully plotting points is something you learned in a previous class, but in case you haven't, the standard is to plot the x coordinate in the horizontal direction, so kind of left and right, and the y coordinate in the vertical direction, up and down. So this point that has an x coordinate of 9 and a y coordinate of 2, I'd move 9 units to the right and then 2 units up and plot it right here. Similarly, this point that has an x coordinate of 6 and a y coordinate of 0 would lie right here. This point that has an x coordinate of 0 and a y coordinate of negative 4 would lie down here. Our next point, which is at negative 3, negative 6, isn't quite going to fit on my graph, but I guess loosely speaking it would be, I don't know, somewhere down here. And if I felt the need, I could plot this 10 8 thirds point, It would be a little bit tricky to do so, but my x-coordinate would be 10, so I'd be over here. And 8/3, let's see, 9/3 is 3. So I guess this would be somewhere a little bit short of 3. So loosely speaking, I don't know, somewhere in here. Whatever, good enough. If you're kind of clever, you might notice that all these points kind of line up. That's not a coincidence. The reason these are called linear equations is because when you graph all the different solution pairs, those solution pairs fall on a straight line. And that straight line is not just a way to confirm that we had a linear equation in the first place. That straight line is really powerful. Any of the infinitely many points that lie somewhere along this straight line would be a solution to this linear equation. So rather than stare at this equation and try to come up with these different pairs, I could come down here to this line and note that the line appears to go through this point right here where the x-coordinate is 3 and the y-coordinate is -2. And because it goes through this point, I won't be at all surprised to learn that when I plug in x equals 3 and y equals -2 into this equation, I get a solution to this equation. In the interest of keeping these videos as short as possible, maybe I can give a quick recap of what you were supposed to have learned so far and leave you with an example to practice on. So the first thing, it would be nice if you could look at an equation like this and recognize that this is a linear equation. This specific equation has 3 terms, and you can recognize that it's a linear equation because each of the terms is either a constant, a number, or a number times one of our variables, the letters x and y. With linear equations, like all equations, really what we're interested in are the solutions to the equations. Because we have 2 variables, the letter x and y, our solutions won't be numbers, but rather pairs. We can write these solution pairs like I did over here. What makes these specific pairs solution pairs is that if you change all the x's in the equations into, say, -3 and the y's into -6, the left side of the equation will be the same as the right side of the equation. These are 5 specific solution pairs, but really what we want is to understand all the different infinitely many solution pairs. And a way you can get there is by graphing the solution pair. If we take the 5 that we found algebraically and plot those on our coordinate plane, we notice that those points all fall in a straight line. And that's not a coincidence. In fact, that's why these things are called linear equations in the first place. And that specific straight line is super important. Any of the infinitely many points on this line will be a solution to this equation. So you can think about the graph as a way to represent the infinitely many solutions, or you can think about the solutions as a way to come up with the graph in the first place. To see if that all made sense, maybe I can leave you with a little practice example. Suppose I gave you, 5x equals 10 minus y. Sure, that'll work. Could you look at this and tell that it's a linear equation? Could you find, maybe 3 different solution pairs? And then can you plot those pairs on our coordinate plane here and make sure that they all fall in a straight line? If so, I think you learned everything that you need to learn for this intro video.